So even though the natural logarithm and natural exponential functions are the ones that we're going to use the most often, namely the ones that are base e, we can have bases that are other numbers. And that's what this is about. So what if we have a base b that is greater than 0, because we have to have a positive base, but not equal to 1, because 1 to the x would do us no good. 1 to the x is always 1, 1, 1, 1, so it doesn't do us any good at all. So the general exponential function, b to the x, can be defined as e to the x natural log of b, which of course due to the power property means I could pull that x up, and it's e to the natural log of b to the x. And since e and natural log are on inverse functions, they would unravel each other. It's a weird way to define it, but it's true. All right, now there is a change of base formula, and we've seen it before. It was on our quick reference sheet. So there's a change of base formula. So if you have a logarithm as a base you don't like, you can always turn it into the division of a natural logarithm. So it's this change of base formula, but I'm using natural log divided by natural log because I'm assuming natural log is more convenient for us. All right, so natural log over natural log. Then the derivative of a natural log should be on our general sheet. So let's look at our quick reference sheets for the derivative of natural logs and the derivative of natural exponents. So on the derivative quick reference sheet, the derivative of a logarithm that is, sorry, not natural logarithm, a general logarithm is right here. And the derivative of general base is right here. So any base and any logarithm. See, these are number 12, and this is number 10. And both of these are on the quick reference derivative sheet. All right, that's easy enough. Now, what about the integral? I wrote it with x, but it would actually work with u as well, as long as this was du. And that's the way I actually put it on the sheet. So sorry about that. I'll fix that for future. So if you look at the quick reference sheet, because it's basically always assuming you're using some types of U-substitution, because, otherwise it's really, really easy. So if we look here on this sheet, it's right here. The integral of b to the u is 1 over the natural log of b times b to the u. So it's that one. So it's number 7 on the integral sheet. There's only one derivative sheet, so I can just say derivative sheet. But for the integrals, we'll actually get another one. So we're referring here to the quick reference sheet. Okay, so let's use those rules to find some derivatives, and then we'll use it to find some integrals. So let's do some fun stuff. All right, derivatives should not be so bad. I mean, we've done a lot of derivatives, and basically everything involves chain rule. Okay, so f prime of x would be equal to, now we take the derivative of the outermost portion first. The outermost portion is the log base 7. So that means that you take 1, if you look at it right up here, derivative of a natural logarithm, or excuse me, general logarithm. Sorry, I keep saying that. So it's 1 over the natural log of b times u of x times u prime of, or times u of x in the denominator times u prime of x in the numerator. So I'm going to say it's 1 over the natural log of b, which for me is 7. That's my natural log. And then down in that denominator, I'm going to put my u of x. And my u of x is 4x. It's right here. So I'm going to say 4x, there's my u of x. And then in the numerator, I'm going to put u prime of x. So up here, I'm going to do u prime, and u prime would be 4. So you can either say it's 1 divided by that times u prime, which is 4, or you can actually put the u in the numerator. That's fine also. So this is u prime. And this is 1 over the natural log of b times u in the denominator right there. Okay, so the 4's will divide away because I have a 4 in the numerator and I have a 4 in the denominator, so they're going to go. And that leaves me 1 over x times the natural log of 7. That's the derivative. Okay, now g prime of x. G prime of x, okay, it would be this rule. So we would use rule number 10 here. So we take the natural log of b, so that would be the natural log of 13, times b b to the u, so we just leave it alone, 13 to the 9x times u prime. So this is the natural log of b, this is b to the u, and then now I need to multiply by u prime, and u prime is 9, because there's u right there. U is 9x, so u prime is 9. And that's pretty much it. I mean, we probably wouldn't write it in that order. We'd probably put the 9 in front. So it's the 9 natural log of 13 times 13 to the 9x. That's the derivative. And I know you're tempted, at least I think you're tempted, to multiply 9 times 13, but you cannot, because 13 is raised to the 9x. That's an exponent, and that's just multiplication, right? Please excuse my dear Aunt Sally. Exponents beat out multiplication, so you actually just have to leave it like that. So to be clear, this used rule number 12, and this used rule number 10, again on the derivative sheet. But what about the integral sheet, you ask? Well, it's nice that you should ask that, because that's exactly where we're going. All right. So we are going to take some integrals here. Now, obviously, these are going to use U-substitution. I mean, they're very obviously not just basic. So U, rather obviously, is screaming out to me that it's x squared. Du would be 2x dx. Well, I want the x and the dx, but I don't want the 2, so it's a half du is equal to x dx. And that means when I rewrite my integral, it's 1/2 integral 8 to the u du, which according to number 7 on our sheet, if we look on our integral sheet, we're using number 7, which is this one, right? The integral of b to the u is 1 over the natural log of b times b to the u. So according to number 7 on the integral quick sheet, would be equal to 1/2, because that's still sitting there, and we haven't done anything with that. And then it'd be 8 to the u times 1 over the natural log of 8 plus c. Okay, so this would be 8 to the x squared, because that's what u was, over 2 natural log of 8. And then plus c. Now, real quick, they might get you on simplifying this one, because 8 is 2 cubed. So this is 2 cubed to the x squared. So that's 2 to the 3x squared over 2 natural log of 8, right? Because 8 is 2 cubed, right? So that's why that's happening. Sorry, my cube got weird there. There we go. And then 2 cubed, and this is 2 to the 1 right here. So that'd be 2 to the 3x squared take away 1 over the natural log of 8. I don't know that they would do that, but just in case you want to be sure. All right, that's a way you can modify that problem. But I'm perfectly happy with this as an answer over here on the left. All right, let's kick it up one more notch. Let's find this one, but this is a definite integral. So we're going to have to do a little bit more work here. Now again, I think it's pretty obvious what u is. U is the natural log of x because it's nested inside. And then du is 1 over x dx, which is perfect because that gets us the x in the denominator and the dx we wanted. Life is grand. Now what we have to do a little bit of work is the numbers for the definite integral. So when x was equal to 1, u is equal to the natural log of 1, which is 0. So we're going to go from u equals 0 as our bottom number, and then, or our lower number of integration, and then our upper number of integration, our higher number, would be when x is equal to 2e, u is equal to the natural log of 2e, which is the natural log of 2 plus the natural log of e based on the logarithmic properties, which is the natural log of 2 plus 1, believe it or not. Okay, so let's see here. When I take my integral, My integral was from 1 to 2e, but it is now from 0 to the natural log of 2 plus 1. Oh, and I'm just going to put a big line in here so I don't get these two problems confused here. All right, and then it's going to be 3 to the u du. Okay, but 3 to the u, according to number 7 on that integral sheet, I guess I'll go lower actually. Let me just kind of move down here. So according to number 7 on the integral quick sheet, and you might as well get used to writing these formulas down. It's okay if you have these ones memorized, but you are going to eventually have to write some down. All right, so this would be 3 to the u divided by the natural log of 3. We don't have to worry about the plus c, but we are taking it from 0 to the natural log of 2 plus 1. Okay, I can pull the 1 over natural log of 3 out because that's just a constant. Sorry, this is all kind of aside work. All right, so 1 over the natural log of 3, and then it's 3 to the natural log of 2 plus 1 minus 3 to the 0. 3 to the 0 is 1. So this is 1 over the natural log of 3 times 3 to the natural log of 2 plus 1 minus 1. Now, if you're thinking, hey, could I manipulate that just a little bit and change it? Yes, you could. Remember that 3 to the a times 3 to the b is 3 to the a plus b, right? So if I have 3 to the natural log of 2 plus 1, I could rewrite that as 1 over the natural log of 3, 3 to the 1 times 3 to the natural log of 2, which would be 1 over the natural log of 3, 3 times 3 to the natural log of 2. You don't have to because it wasn't asked for, but just so you understand that those are one and the same. It doesn't hurt to remind ourselves how algebra works, because algebra can often get us on these problems.